Welcome to this activity, which is an application to economics. Here we're going to optimize the profit function given the demand equations for two types of chairs. So the store sells two brands of company chairs. The store pays $60 for each brand A chair and $80 for each brand B chair. The research department has estimated the weekly demand equations for these two competitive products to be X equals 260 minus 3P plus Q, which is the demand equation for brand A, and Y equals 180 plus P minus 2Q, which is the demand equation for brand B. The P and the Q here represent respectively the selling prices for brand A and brand B, and the X and the Y are the quantities. So the question is, how should the store price each chair to maximize the weekly profit, and what is the maximum weekly profit? So let's start with computing the revenue function. Since the question is about the profit, we're going to first compute the revenue, then find the cost function and maximize this profit. Okay, so let's start with the revenue function. Here I will use the demand equations to find the revenue function. Remember that the total revenue is equal to the quantity times the price for the first type of chairs and the quantity times the price for the second type of chairs. So it's the sum of the two individual revenues. Here we have X as a function of P and Q, Y as a function of P and Q. So we're going to substitute the X by its expression and the Y by its expression, and we're going to find a function of P and Q. It's not a function of X and Y, but it's a function of P and Q, because we're going to substitute the X by its expression. So it's 260 minus 3P plus Q times P plus 180 plus P minus 2Q times Q. Now you expand this expression, you're going to find that it's 260P minus 3P squared plus PQ plus 180Q plus PQ again minus 2Q squared. You can write it as minus 3P squared minus 2Q squared plus 2PQ plus 260P plus 180Q. Now, we'll also need to write the cost function. And to be able to write the cost function, we need to know the prices of each type of chair. So we go back to our problem, and we can see here that the store pays $60 for each brand A chair and $80 for each brand B chair. So the cost will be 60 times the quantity of chairs of brand B plus 80 times the quantity of brand B chairs. So here we can write that the cost function is 60x. So the cost is equal to 60x plus 80y. Again, here we have to substitute the x and the y by their respective expressions to get the cost function as a function of P and Q. Since the revenue is expressed as a function of P and Q, the cost function has to be also expressed as a function of P and Q. So let's write C of P and Q, which is equal to 60 times 260 minus 3P plus Q, which is X, plus 80 times 180 plus P minus 2Q. Now we expand. So 60 times 260 is 15,600 minus 180P plus 60Q plus 14,400 plus 80P minus 160Q. Now, after simplification, you will get 30,000 minus 100P minus 100Q. Now, to compute the revenue, you will take the revenue function, to compute the profit, sorry, you have to take the revenue function and subtract the cost function. Be careful, when you subtract, you have to invert the signs inside the cost function. So let's just write the final answer here. So the profit function will be a function capital P of the variables small p, q, equals, we have minus 3p squared minus 2q squared plus 2pq. We have here plus 260p, and here it becomes plus 100p, so it's plus 360p. We have plus 180q plus 100q, so it's plus 280q, and minus 30,000. So this is the profit function. Now, the question is about finding the maximum profit. Here we're going to use the second derivative test, and to use the second derivative test, we need first to find the critical points. So we have to compute the first order partial derivatives. The function is capital P, the variables are P and Q. So here we have two partial derivatives, capital P, P of P and Q. And you compute the partial derivative of this function with respect to P, you will find that it's minus 6P plus 2Q plus 360 equals 0. The second partial derivative you have to compute is PQ of P and Q. It's equal to minus 4Q plus 2P plus 280, set it equal to 0. Now, from the first equation, we conclude that if we write here Q, you will find that Q is equal to 3P. Okay? You move the negative 6P to the other side. You move the 360 to the other side. You divide by 2 to get Q. So you will find that it's 3P minus 180. Now, you include this Q, the expression of Q, in the second equation. You will find that its times negative 4, so you will find negative 12P. Okay? Minus 4 times minus 180 is 720. Okay? Plus 2P plus 280 equals 0. So you obtain an equation with a single variable P in the second position here. So let's solve it and then conclude the value of Q. So the second equation here, so we have Q equals 3P minus, so 3P minus 180. Here, negative 12P plus 2P, which is negative 10P, plus 720 plus 280, so plus 1000, equals 0, which is equivalent to Q equals 3P minus 180, and 10P equals 1000, which is equivalent to P equals 100. So we found P, we compute Q, so Q will be 300 minus 180, which is 120. So one critical point. Which is P equals 100, Q equals 120. So the second step here is to use the second derivative test to check that it's a maximum. I put here the first order partial derivatives to be able to compute the second order partial derivatives. So let's compute P of P and Q, which is equal to a constant here since it's equal to -6. We have also to compute PQ of P and Q, and here it's equal to 2. The third partial derivative is PQQ, P and Q, which is equal to -4. A, B, and C. Now, you compute AC minus B squared, and you find that it's -6 times -4, so 24, minus 2 squared, it means -4, which is 20, so greater than 0, and the sign of A is negative, so and A is less than 0, so it's a maximum, so it's a local maximum. So the point you found here is a local maximum. We are looking for the maximum profit, so we are done. We know that the profit is maximum at P equals $100 and Q equals $120, which are the selling prices for the two brands of chips. Now, the second part of the question is, what is the weekly maximum profit? Then you have to compute the value of P. So let's write that the maximum profit is equal to P of 100, 120. So these are the prices which maximize the profit, and you have to substitute the P and the Q by these values in the profit function. So after computation, you find that the maximum profit is $4,800. So for P equals $100 and Q equals $120. So we are done with this activity. See you in the next videos.